Morning, everybody. Go ahead and continue where we left off last time. So just a reminder, this 2.1 section, this one is going to be due this coming Sunday. And so we'll go ahead and continue. So where we left off last time on 2.1 was we did talking about the difference quotient. So we could just go ahead and review that here. So difference quotient is this formula right here. And what that is a way to find a slope. And usually we use it to find the slope of a curved line. But we did this one example last week where we put everything all into this formula and we got 2, which is to be expected because that is the slope of this original line. So instead of a line like this, let's now take a look at another example where we have a quadratic, and we're going to go through that. So this is not a straight line, and so we're going to go through and find the difference quotient here. So first of all, when we do these kind of problems with the difference quotient, you want to start with the formula. So we have f of x plus h minus f of x all over h. This is always the same formula you're going to do every single time. Now I'm going to do this part, this f of x plus h. I'm going to do that off to the side over here. Then we'll put it back into the formula a little bit later. I want to find f of x plus h. So I just want to talk about that separately here before we jump back into the formula here. With our original formula, if you have x plus h, what that means is that every x that you see in the original equation is going to be replaced with x plus h. So if I take the original equation and get rid of the x's, then it looks like this. I have 3 times a blank squared and minus a blank and then plus 1. So the blanks get filled in with x plus h. So I'll put that in to each of these here. And that's always how you find f of x plus h. Remove the original x, replace it with x plus h in the formula. But we want to go ahead and simplify this further. Now we need to remember our order of operations on this. Let's take a look at this first term, this 3 times x plus h squared. First of all, the 3 is not allowed. We cannot take the 3 and multiply it inside and make it 3x plus 3h because order of operations says that the exponents come first before multiplication. So I want to multiply this out. Now remember, this right here really means x plus h times x plus h. So you can't take the 2 and distribute that and make it x squared plus h squared. That's not correct. You have to remember to multiply it out here. This is like a FOIL that we're going to do on that one. So let's do that now. The 3 I'm going to leave alone, and I'm going to multiply this by using the FOIL. So x times x is x squared. Then I have an x times h and another x times h. If I add those together, I get 2 of them. So I get 2xh, and then I have h times h, or h squared. Oops, forgot the square there. Okay, so I have that. So the 3 is still on the outside of all this. So I did the square part first. Then the rest of it, I'm just going to distribute the minus sign. So minus x minus h, and then I have plus 1 on the end for that. Now that I have expanded this, I am allowed now to multiply all this by 3. So f of x plus h is going to be 3x squared plus 6xh plus 3h squared minus x minus h plus 1. That now is my entire expression for f of x plus h. So I wanted to do all this separately because now what I'm going to do is come back into the original difference quotient formula and substitute this in. So I have 3x squared. So now I'm replacing the f of x plus h with all this that I just expanded. 3x squared plus 6xh plus 3h squared minus x minus h plus 1. So all of this right here is the f of x plus h. So I'm just kind of labeling all that for you right there. So all this is f of x plus h. This is an h right here. Okay. Then I have a minus sign because that's part of the difference quotient formula. And then I want to put the f of x in exactly as is. So 3x squared minus x plus 1. This is the f of x. All that is over h. So this, now you can see exactly what's being put into this formula. I did all this over here to find out what f of x plus h is. I expanded all that out and put that in first part of the formula here. A minus sign is part of the difference quotient formula. And then f of x is the original equation that they gave us. So I have both these pieces in there. The next thing we're going to do is we're going to distribute the minus sign. This is actually a very important step. Now you could go ahead and automatically reverse the signs when you put this in, but I like to write it out this way so that way you can see exactly all the steps that's happening with this. So that I'm not going to do anything with this f of x plus h. I'm just going to write all that out. But then I have minus 3x squared plus x minus 1. All the signs got switched there because of the minus sign out front. If you're subtracting the entire thing, you need to put these parentheses here. If I just put minus 3x squared and then everything else was the same, that would be incorrect because the minus sign needs to distribute through everything that you see there. So then it changes all the signs that you have. So now that we have this, this is actually important because you're going to start noticing some things are going to cancel out. So if you don't do these signs, if you do these signs incorrectly, you're not going to get all this to cancel out. So 3x squared and negative 3x squared cancel out here. Negative x plus x cancel, plus 1 and minus 1 cancel. So if we rewrite this without all that in there, we get 6xh plus 3h squared, and then I have a minus h here. All that is over h. Okay, so everything else cancel. If you did this correctly, you should only have things that have h in it left over. If you have an x squared still left over or a number, then you did something wrong and you want to go back and check. Probably you forgot to distribute the minus sign in that case. You should always get all that to cancel out, and you should only have things that have h in it left over. And the reason why that occurs is because that way you can factor out an h and cancel the h out of the denominator. You always want to try and cancel the h out of the denominator if you can. And all these here, you should be able to definitely do that when you cancel that part out here. Okay, so someone has a question. Someone have a question out there?
Yeah, good morning, Professor. I had a quick question. Would we ever have a problem to where we'd have x in the answer?
Yeah, you'll have an x in the answer and you also have an h in the answer. And so what's going to happen, for instance, that's going to happen on this problem right here, because if I factor out an h from that, I'll be able to cancel the h's out of the bottom. And I do, in fact, get an x as part of my answer here. But you should always be able to cancel out the h in the denominator. That should always happen on these problems. You should never end up with a problem where you're dividing by h. That part will never happen. You should always have the h's cancel in this case. But it's possible that you may have an x and an h in your answer, and that's perfectly fine. This answer, you would just put this in as is. So it's okay to have x's and h's in your answer. The one we did yesterday, or on Thursday, where we got a 2, that was only because it was a linear function. So if it's linear, you're always going to get a number answer on that. But if you get something that's like a quadratic or a cube or something like that, then you're always going to end up with an x and an h in your answer there. So just to talk to you guys a little bit about what this actually means here. This is actually the beginnings of something that you'll do in calculus. And so the h, what it represents on this, if we look back at our original drawing that we had here, you're finding 2 points on this curved line and you're trying to estimate the slope on this curve. Well, in order to do that, you have to get these 2 points to be very, very close to each other. So this h that's here is how much a little bit more you are past the x. Ideally, you want the h to go to 0, so that way this point goes right on top of the other one, and then you can find what the exact value of a slope is. So on this problem here that we just did, where we have that, in calculus, what's going to happen is this h is going to go to 0, and you'll end up with 6x minus 1. That is actually called a derivative, and a derivative is a function for the slope. It's basically 6x minus 1 would be something where I could find the slope at any point on that curve line that I want. Now, we're not going to go into all that. In this class, all we're going to do is just find the difference quotient only and go down to here, and that's going to be your final answer that you would put there. You don't have to put a 0 in for anything. You just leave your answer as is. And the only reason why I like to talk about this more is I just want you guys to know that for sure, for those of you going to calculus, you will definitely see this again. In fact, this is part of what you're going to be doing in calculus. You still have to make sure you know how to do the difference quotient. When I originally learned difference quotient when I was in school, they never told me what this was for. So I just found it to be unused, a waste of time, and I didn't know why we were doing this in the first place. What's the point of that? And I didn't realize that until I got to calculus of why this is actually important. So that's why I like to mention it now, just to fill you in that it is something you'll see in the future for that. So let's do another one, because there's some different problems that they'll have in the homework that deal with difference quotient. So I want to look at a couple different functions here. So I want to do this one, this f of x equals 3 divided by x minus 1. And so, as always, it doesn't matter what the function actually is, you're still going to do the same formula, difference quotient, every single time. Okay. Now, in this, if I want to find f of x plus h, there's actually not a whole lot I can do on this as far as simplifying. So the x that's here gets replaced with x plus h. So the minus 1 there is the minus 1 that appears here. And there's not any more I can do with that. There's no simplifying. These are not like terms in the bottom. So that's all I can do, f of x plus h. But I'm still going to go ahead and put that in as is. So here is the f of x plus h, and I have minus 3 over x minus 1. And all that is over h. So this is what I have so far. Now, on this problem, if you have something like that is a fraction, as we see here, what you want to do on this problem is to get common denominators. Okay, so we want to get common denominators with these. Now, if you look at the denominators that you have here, your common denominator is just going to be these two things multiplied together. So I want to have both of these denominators end up having x plus h minus 1 and x minus 1. So what we'll do is we're going to multiply each one by what it's missing here. So x plus h minus 1. This one has the x plus h minus 1. However, it's missing the x minus 1. So I'm going to multiply top and bottom by x minus 1 over x minus 1. Then over here, this one has the x minus 1. But it's missing the x plus h minus 1 over x plus h minus 1. So I'm going to multiply that. All that is going to be over h. Okay. So now I'm doing that to get common denominators. Because these now have the same denominator, x minus 1 times x plus h minus 1, what I can do up here is I can put these together over a single denominator. So I have 3 times x minus 1 minus 3 times x plus h minus 1. All that is over the common denominator, x minus 1, and then x plus h minus 1. Don't forget, all this is still being divided by the h. Now this is, the h down there can be written as h over 1. So what I want to do next is I want to change the complex fraction. I have a fraction over a fraction. I want to flip and multiply to make it just one fraction only. So this one I have 3x minus 3. And I have minus 3x minus 3h minus 3. I have all this here, x minus 1 and x plus h minus 1. And then I'm going to multiply this by the reciprocal. So whenever you have a fraction divided by a fraction, you're going to take the top fraction, you're going to multiply it by the reciprocal of the bottom one. So I'm going to multiply this by 1 over h. And so now I've eliminated those double fractions. We have a situation now where we have some things we can cancel out. So I have the 3x, negative 3x cancel on that. And oh, you know what? Right here, there should be a plus 3, negative 3, and negative 1. That's a plus 3 there. So I have negative 3x, negative 3h. That should be a plus 3. The reason why I knew that is because these numbers here have to cancel out. There should only be an h left over when you cancel all this out. So 3, negative 3 cancel like that. And this is what I have left. I have a negative 3h I have on top. This h I could put out front here. And then the last step I'll do is the h's actually cancel out there. And this is what my final answer is going to be. I have negative 3 over x plus h minus 1. And that's it. That's as far as I can go. So again, this is another problem where we see we have x's and h's as part of our answer. That's okay to have that. But in every problem that you do, no matter what the equation looks like, there should be some point in the problem where you cancel an h out of the top and the bottom. So this problem, I canceled the h out of the h down below. The previous example, I was able to factor out an h and cancel. Even that one we did last week, the 2x minus 3, we were able to cancel h's out of there as well. So all these problems, you should be able to always have the last step you'll do is cancel out h's. That's always going to be your last step when you do these kind of problems. So this down here at the end, this is going to be your final answer we have there. And there's no special form. There's no special notation, by the way, for difference quotient. And when you do these problems in my open math, it'll just say difference quotient equals, and you'll just go ahead and type this in. So there's no special notation you have to put for difference quotient on there. So again, the h's cancel on here, h is canceled in this last problem, and then h is even canceled out in that one that we did last week. So all of these here, again, as you notice, every single time you should be able to cancel an h out. If you can't cancel out an h, that means there's something that probably went wrong. You want to go back and check it. You should always be able to factor out an h and cancel it out on every problem that you do here. Okay, so that canceled out. Okay, so now that we're done with 2.1. So that was the last part we wanted to do, was a difference quotient. So we're going to move on now to the next section, 2.2, where we're talking about the graph of a function. All right, so for these, we're actually reading values off of graphs is what we're doing. We're using function notation, but we're reading it off of a graph instead. So so here is the first problem that we'll do. It says, given the graph below, evaluate f of 3, and then we also want to solve f of x equals 4. So we kind of do two in one problems here. With this here, f of 3, what that means is find the y value when x equals 3. That's exactly what this is saying to do. F of 3 means find the y value when x is equal to 3. That's what this translates into. So what I'm going to do here is when x is 3, I'm going to go up like this. And if I take that back to, so when x is 3, I go up to where it hits the graph, and I see what y value I'm at. And I happen to be at 1. So f of 3 will equal 1. And that's the answer. I don't have a formula to plug the 3 into this time. I just have a graph only. So all my values are coming from the graph itself. So when x is 3, I go up to where I hit the graph, and then I go over to find the y value. That's going to be at 1. Now this other one, this here is a y value. So this problem is actually the reverse of the one that we just did. We want to find an x value that gives a y value of 4. Okay, so find x value that gives y equals 4. Okay, so that's what that means here. Find the x value that gives a y value of 4. Well, if I look at the y value of 4, there's actually two places on the graph where I have a y value of 4. Two places here. That's where the graph crosses at 4. Now I just need to look at what x values correspond to that. I have 0 and I have 4. So if f of x equals 4, then x is equal to 0 and 4. Okay, so that would be the answer to the second question. I get two answers, x is 0 and x is 4. So that's how you do that one. Again, just reading that off of the graph, that's the only thing that asks us to do. So that would be my answer on that. F of 3 is 1, and then x is equal to 0 and 4 on the second part. Okay, so now let's do another one here. We have this, and it might be hard to see on your screen here, so I'm going to make these a little bigger. This is -2, 2, this is 2, this is 1, 0 and 1, -1. So just to make that a little bit clearer for you. -1 and -2 down here. Okay, so for this problem, we want to find the domain and the range, and also the intercept. So we're going to find these three things on this problem. All right, so the domain is talking about the x value that the x values the graph uses. So we're looking at all the x values the graph uses would be domain. So again, domain is x, and the range is y. If I look at this graph only exists between the x values of -2 and 2. So my domain is going to be from -2 to 2. Now these are open circles. Open circles means that we're going to use parentheses on that. So if it's an open circle, we're going to use parentheses. And if it's a closed circle, that means we want to use brackets when it comes to using interval notation. Okay, so domain is going to be from -2 to 2, and that's going to be your answer. Okay, so parentheses, these are both parentheses here. Okay, for parentheses because they have open circles. If these are both closed circles, then I have brackets on there for that one. The range is talking about only the y values that are used on this graph. The smallest y value this graph uses is -1, and the highest y value it uses, this is at 1 right here where it crosses. So between -1 and 1. So I have -1 and 1 here. Now down here, we still have open circles, so that has to be a parenthesis. However, notice that at 1, there's a solid line there. There is no open circle. Because there's a solid line there, that means that point is actually included. The only time a point is not included is if you have an open circle. So I have open circles for both of these, but there's no open circle up here on this one. So if there's no open circle, it's always assumed that that point actually exists. So I do have to put a bracket on -1. That's a solid line. That number is actually included on my graph. Now, last thing I want to do is indicate the intercepts. That's going to be these right here, -1 and 1. So I'm just going to list those down. I have -1, 0, and then I have 1, 0. Okay, so I'm just listing all the intercepts off of there on that one. Okay, and then that's going to be that's all that this question asks for. So again, you're just reading off the graph itself. So I got a question. Okay, so domain. I have a question in the chat here. I can explain the domain. So, the domain is talking about only the x values that this graph uses. And if I take a look at the entire graph, the graph only exists between the x value of -2 and 2. There's no more graph that goes less than that or more than 2. So the graph is only defined between -2 and 2. Now, because both of these are open circles, that's why I'm using parentheses on that. So when you give your answer, this is not a coordinate, by the way. So just to let you know, this is not a coordinate. This is interval notation. Okay, so interval notation, I'm starting with the smallest number, the smallest x value the graph uses is -2, and the largest x value the graph uses, which is +2, and I'm just putting those around parentheses. So that's the explanation of that one. So this is just the x values the graph uses, the range is the y values. So again, we go between these y values, -1 and 1. I have, because these are both open circles, that's why I'm using a parenthesis here. But again, this is a solid line, so that's why I'm using a bracket on that one. Other questions? Other questions on this one before we go on? Okay. Let's go on to the next one. Now this one has some different things. I might have to flip up and down the graph here on this, because when I get down here, there'll be other questions. So if you have the guided notes, you should have all this in front of you, so you'll be able to see it all, because I'm basically just using the exact guided notes that you have on that I gave you on my website. But so this one here, notice this time that everything is closed circles. So you know what we're going to do first? Let's go ahead and jump down to domain and range first, and then we'll jump back and do these other ones. Since we're just talking about domain and range in the last problem, let's do another example. Since we had a question on domain, let's do that for this particular problem. So I want to find domain right here. Now domain is talking about the x values that the graph uses. The smallest x value that the graph uses is -4. The highest x value that's used is 6. So I know my domain is going to go from -4 to 6. Now, since both of these are closed circles this time, I'm going to put brackets on both of these. So I have a bracket, -4, and that's going to go all the way to 6 with a bracket. Again, these are brackets because these points are included. These are closed circles that we have on that. So that's going to be my domain. Let's talk about the range since we have this picture here. So the range is talking about the y values the graph uses. The lowest y value is -2, and the highest y value is 3. So my range is going to be from -2 to 3, and both of those are going to have brackets. Again, the smallest y value, that goes first, and then the highest y value, which is 3. So I'm going to go from -2 to 3, and both of those have to have brackets on it as well, because the original graph had closed circles for everything. So I wanted to go ahead and just continue and do domain and range on this question, just to follow off of the last one, just so you can see the difference there with it. So these are all brackets because I have closed circles on that one. Okay. Now let's jump back up and do these first questions here. So A says find f of -2. So really, again, what it means is find y when x equals -2. And when I find the y value when x is -2. Here's -2 here. We go up to the graph. In fact, at this point, this is easier than this is even easier than the previous problem because it actually tells you what the y value actually is. So when x is -2, the y value is 1. So now I know that f of -2 equals 1. Okay. The 1 just comes from the y value at this point right here when the x is equal to -2. So f of -2 equals 1. Next, it says, find all the x values such that f of x equals 3. So again, this is basically saying, find any x value where the y value is 3. So again, that's the y value there. Okay, so find all x where y equals 3. That's basically what that says. Well, there's only one spot on here where I see a y value of 3. That's going to occur at this point, 5, 3. So my x value is just going to be equal to 5. So f of 5 will equal 3. The x value at 5 it equals the y value of 3, and that would be it. So that's all you have to put in this one, x equals 5. Part C, is f of 3 positive or negative? So I want to look at the x value of 3, and that's going to be about right here. And I'm going to go ahead and follow this down to where it hits the graph. So at the x value of 3, I want to find where the y value is. And the y value ends up being somewhere down here, maybe negative 1.75, somewhere around there. But all it's asking for is whether it's positive or negative. So at the x value of 3, because it's hitting the graph below the x-axis, that means it's going to be negative. And so my answer there, it's going to be negative. Okay, so f of 3 would be negative there in that case. So again, it's just talking about whenever you see this notation, you're always talking about the y value when x is 3. So it's saying, is the y value when x is equal to 3 positive or negative? Well, that y value will be negative because that's below the x-axis and ends up hitting somewhere. It's the graph down below here. That would be your answer on that one. Okay, let's do another one of these. So we have some new ones now. Okay, use the graph below. Now this one we have right here. I'll highlight it. That's an open circle there at that point. And there's a closed circle. And this one right here. So open circle there right down here and a closed circle on that one. All right, so let's answer these first couple questions. So again, this graph should be in your guided notes for you. You can just read off of there. So we want to find f of negative 1. This is saying again, find the y value when x is negative 1. When x is negative 1 right here, I'm going to go up there and it's hitting. So at negative 1, hits the graph at the y value of 2. So f of negative 1 equals 2. That's the y value when x is negative 1. Next, find all x such that f of x equals 0. So where the y value equals 0, that's another thing. Basically, wherever it crosses the x-axis, that's essentially what this is saying here. So when it says f of x equals 0, essentially what that's saying is this actually means x-intercepts whenever you have something like that. Remember when we talked about x-intercepts before? X-intercepts, you put a 0 in for y and solve for x. So the y is 0 here, and you're just finding the x values. Okay, now it's not asking you specifically for an x-intercept. It's just saying find the x values that make it 0. So all I need to do is, I don't need to list them out as coordinates in this case. I'm just going to write it as x equals. So that's going to be at negative 2, then at 3, then at 5. Okay, so at these 3 places, that's where the graph crosses the x-axis, and that's also where the y value would be 0. Then I have another one of these, is f of negative 3/2 positive or negative. Now this right here is the same thing as negative 1.5. So negative 3/2, same thing as, you can do that in your calculator, negative 1.5. So I'm going to go to negative 1.5 is right here. And I'm going to take that up there. And I hit the graph somewhere around like 1.5-ish, somewhere around that point. So when x is negative 1.5, the graph is hitting above the x-axis, which means that f of negative 3/2 is positive. Okay, it's not asking me for the exact value. I just want to know if it's positive or negative. So at negative 1.5, it's hitting the graph above the x-axis. That means that's how we know it is positive. All right, so next one that we'll do is we want to find the domain and the range. So domain is next. Now remember, there's an open circle and a closed circle there. The smallest x value, because again, domain is x values. The smallest x value the graph uses is negative 3, and the highest x value it uses is 6. So my graph runs between negative 3 and 6. because that's an open circle, I'm going to put a parenthesis here. And because that's a closed circle at 6, I need to put a bracket. Okay, so I have a parenthesis and a bracket on each of these. Again, what tells you that is the open circle and the closed circle will tell you this particular one here. So again, bracket at 6 only because that's a closed circle and there's an open circle there at the end that was originally given. Let's talk about the range. The range is talking about the lowest y value and the highest y value on here. The lowest y value is this, -4. The highest y value is 4. Now there's an open circle. I have it -4, but since it's a solid line there, that's a closed circle. So I'm going to have, when I do my range, is I'm going to have a parenthesis at -4, but I'm going to have a bracket on the 4. Okay, so my answer is going to be from -4 to 4. I have to have a parenthesis because it's an open circle there at -4, but there was a solid line at 4, so that's why I'm putting a bracket on that one. The last thing is it says find the x and the y intercepts. Okay, so x and y intercepts, it's really the same thing as part B. It's the same exact points, -2, 3, and 5. The only difference is I'm going to put these in intercept form, which means I'm going to put the -2, 0, 3, 0, 5, 0. Okay, so I'm going to put that down here. -2, 0. We have there. We have this point, 3, 0, and 5, 0. So really, that's the same exact thing as the previous part that we did. The only difference now is we're writing these out in intercept form, where we put the zeros and the parentheses around it. Whereas up here, all they wanted was the x values. That's the difference between those. Because it actually didn't say the word X-intercept, that's why we didn't do that on part B. But because this actually specifically asks for intercepts, that's why we have to write it in that particular form. But again, it's always just the same as these points that you see here where it crosses the x-axis. That's the x-intercepts it wants. So this wants you to indicate the coordinates of those. That's what we did. All right, so we got some more things that we'll continue with here. Okay, it says determine whether the graph below is that of a function by using the vertical line test. If it is, use the graph to find, okay, we got domain and range we want to find, intercepts, and symmetry with respect to the x-axis, y-axis, or origin. All right, so first, we want to try the vertical line test. So now if you pass a vertical line down here or here, notice that it's only going to hit the graph one time, no matter where I draw this vertical line. It's going to hit the graph once. Okay, so I know for sure, because I'm dropping this vertical line down like that, I know that, so I'm going to get rid of these lines now. I've already did the vertical line test, and so I know, let's see, so this graph is a function, okay? Okay. So we know it's a function because we did the vertical line test, and anywhere you pass a vertical line all the way through here, like here, or this line right here, or that line, that means it only hits the graph once. If it hits the graph more than once, it's not a function, but in this case, it only hits the graph once, so we know it is a function. Okay, so now, if it is a function, now we have to do these different parts now. So let's do part A. We want to find the domain, and we want to find the range. Okay, so domain and range. Now, what makes this problem different than the ones that we did before is notice that this problem does not have open or closed circles. Essentially, what this means is that this graph goes down here forever. Okay, so it keeps on going down there. So whenever you have that where you have a graph going forever, it means that your domain and range are going to have infinities in them. Okay, so first, let's talk about domain. Domain is talking about the x values that the graph uses. Now we're going to assume that this graph keeps going down here forever. Now, as it does, it's going to get wider and wider and wider, and this gets wider and wider as it goes that way. So no matter what, the graph is getting wider and wider as it goes down. That means the wider it gets, the more x values it uses. And it's going to keep getting wider forever. So we can say that the domain here is actually going to be negative infinity to positive infinity. It's using up all the x values because as this gets wider and wider, it's going to just keep using more and more y value or x values forever. Now the range, that is limited by what we see here. Okay, now certainly it does go all the way, it keeps going down forever. So it's going down to negative infinity. So I'm going to start with that here, negative infinity. But it goes up to 1. Okay, so this is 1, 2, 3. It doesn't go higher than a 1. So that means that the range has to stop at 1. And because it's a solid line here, we don't see open circles. That's why I'm using a bracket on the 1. So it goes all the way down to negative infinity, but the highest y value that it ever reaches is going to be a 1. Okay, so that's why I have that there with a bracket. So that's part A. Part B says, find the intercepts. Okay, intercepts are going to be these 3 here that I'm circling, these 3 points. That's where the graph crosses either the x-axis or the y-axis. So we want to do x-intercepts. X-intercepts would be where it crosses the x-axis here. So I have -1, 0, 0, 0, and 1, 0. Just read those directly off the graph. For the y-intercept, it only crosses the y-axis down here at 0, 0. So as I mentioned before, 0, 0 is always an x-intercept and a y-intercept at the same time. And so that is the answer for that one. Okay, so just reading those off the graph. Then part C says any kind of symmetry. So they want to know whether this has x-axis, y-axis, or origin symmetry. We talked about that last week. That was in section 2.1. So what we want to do is look at the graph and see if we have any kind of fold lines. So if I fold the graph over on top and it can lay on top of itself, and that has its symmetry. One thing I will notice right away is the y-axis here. If I fold this along the y-axis, I'll fold this over, and then this part will lay perfectly on top of that part. So I know it has y-axis symmetry for sure. Now it does not have x-axis symmetry because if you fold that over, that's not going to lay on top of itself. And in order for it to have origin symmetry, I have to have a mirror image, like this one here, and then it has to go down below like that. I don't have that in this case. So it doesn't have origin symmetry either on this. So it only has y-axis symmetry. Now I had a question to ask the chat about how do we get the domain again? So the domain is talking about the x values the graph uses. As this graph goes down, it's going to get wider and wider. So the graph might keep going down like this. So as it keeps going down further and further, the graph is getting wider and wider. As it gets wider, it's using more x values. So because of that reason, it's going to keep getting wider forever. So all the x values it's going to use is between negative infinity and positive infinity. It never goes vertical, where it'll go completely vertical here. We don't have that situation. It's getting wider and wider as it goes down. That's why we're saying that the domain is going to be from negative infinity to positive infinity. It's going to use all the x values on this. All right, any more questions on this particular problem before we go on to the next one? Okay, let's go on to the next one. And oh, there is no next one. Okay, this is the last problem that we had on this. So I'm looking through your homework just to see if there's anything different that we didn't cover as far as that. And it looks like we have This is similar. So it's a section only actually has 8 problems in it. So 2.2 is a pretty short section. It was just on a couple graphs. So pretty much everything that we covered is going to be on there. There is one question in particular that I'm going to pull up for you. And so let me pull up this question. I'm going to go into do a new share here. Let's share this question. Okay, so here is another type of question that you're going to see in here. And so I don't have notes on this, but I'm just going to go ahead and explain basically how you would do this kind of problem. So this graph right here, it's going to give you something similar to a graph that looks like this. And it kind of explains to you how you're going to do each of these, but I just want to go ahead and explain how you would do that. So part A here, it says f plus g of 3. So I put a little, this question also tells you what exactly they want you to do by that. So f plus g of 3 is the same thing as f of 3 plus g of 3. So the red line, it says f of x here. It's hard to see, but it says f of x. And the blue line is g of x. So all you're going to do is you're going to go to the value of 3, which it is right here. And we got these dots already here conveniently for us. So it says we want to get so this is saying we want to find the y value when x is 3 on the f graph. So that is going to be 3. And then g of 3 is going to be at -1. So really what I have is, I'm just going to kind of write, since I don't, instead of switching back and forth, I know it doesn't want you to write it this way, but I'm going to kind of do this in steps just to show you. F of 3 was 3, put that in there. And I'm adding -1, but of course, when you enter this in MyOpenMath, you're not going to write it out like this. You're actually going to go ahead and put 2 in there, which again, this is the answer that we have. So 3 minus 1 is 2. So you'll just type 2 in there for the answer, and that'll be it. And all the other ones are kind of self-explanatory what it is. You've got plus, which means you'll get f of 5, which is 1, and then f of the g of 5, which is -5. So basically, you're going to add 1 plus -5, and so you get -4 is the answer. And we have a minus here. So all these really are doing the same thing. So again, the dot is right there. Now in this case, f of 7 and g of 7 are actually both the same thing. They're both -1. So on this, you'll have -1 minus a -1. You're going to get a 0 on that, and for that one. And all the other ones, again, you'll just read the values off the graph and just follow the instructions, what it tells you to do. So that one's, we didn't have one of those in the notes, but again, it's similar based on what we've done so far by reading values off of graphs. That's essentially what you're doing here. We just have 2 different functions on it. They're both different colors, but they're also labeled for you as well, f of x and g of x that we have on there. So that's the only other problem that looks a little bit different from what we've done. Everything else is things that we've covered in there. All right, so let's go back to the notes again. Okay, so let's go back to the written notes. All right, so now we're going to go on. So this again was a very short section, and so we're going to go on to 2.3. So this one we're not going to finish today. We're just going to go ahead and start it, and then we'll do more of these next time. So this 2.2 and 2.3, they kind of go together, and they can almost be thought of as one big section, although this book separates it into 2 different sections. But you're still talking about reading values off of graphs. So when you see a question like on a test, for instance, you're actually going to have one problem that's going to have both 2.2 and 2.3 together. So it's going to kind of just be one big problem where you'll be reading values off of a graph and things like that. So that's what we're going to be talking about here. Now 2.3, we have some definitions. So I'll go ahead and let you read those definitions. But increasing, we have so if the graph is an uphill part, looks like this, then we have a downhill part. So if it's increasing, the graph is going uphill as you move from left to right. So as I go from left to right, I see an uphill portion. If I'm going from left to right and the graph is going downhill, then that means the graph is going to be decreasing. If you have a constant part, that means that you actually have part of the graph is a horizontal line. And so we have that right here, so horizontal line. A relative max means that you've got something that goes like this, where it increases and decreases, and then this other one is a valley, like that. And I want to talk about the difference here. Let's do one like this. This graph that I drew in here, it's got relative max and relative min in it. Now, notice that this doesn't have to necessarily be the highest and the lowest point on the graph itself. Okay, the graph goes down lower and higher. So this example that I drew here, you can still have a relative max and a relative min. What the word relative means, this means that relative to the area that you're at. Now, these are also sometimes referred to as local maximum and local minimum. It depends on what book you're using and also what teacher you have. Like, for instance, for calculus, you may see that referred to as local max or local min on there, but it means exactly the same thing as relative max, relative min, just different terminology. The word local just meaning that locally in this area, that's the highest thing around. And then locally, this is the lowest thing around, but it doesn't necessarily have to be the highest and lowest point on that graph. And in this class, we're saying that it's only going to be a relative max if you have a increasing and a decreasing part that comes after it. You have to have both pieces. So if you look at this graph down below here, where I've got these points labeled, this point down below here, this 4, 2, that's not going to be considered a relative max in that case. The reason why is because I don't have a decreasing part that comes after it. So in this case, the relative max is going to occur only at the point 0, 3. The relative min only occurs at the value of 2, 0. This point here, -3, 0, would not be considered a relative min because I don't have a decreasing part that comes before that. So this part here is not, this -3, 0 is not considered a relative min. Only the 2, 0 is, because I have decreasing and I have increasing there at that point. So that's kind of describes all that. So let's take a look at this graph. We're going to answer some of these questions. Since we're just talking about relative max and relative min, let's go ahead and answer this here. Now, the way they ask these questions, though, you're not going to be listing a coordinate as your answer. You have to look at the way that the question is asked, and you'll actually see it asked the same way when you do the homework assignments on that. So you will actually see this particular phrasing that you'll have, list the number. You might also see it as list the number at which you might see it indicated in there. So for this, it says list the number where f has a relative max. So this, it says list the number. This phrase right here means x. Okay, so it says list the x values where f has a relative max. Well, the relative max occurs here, this point, because we have an increasing and decreasing part. The x value is 0. So that means I'm just going to put 0 as the answer. You don't have to put x equals. All you have to do is just put 0 down for that. Okay, you're indicating the x value for which the graph has a relative max. This one says, what is the relative maximum? Okay, this is referring to a y value. Okay, so when it says what is the relative maximum, you're not going to list the coordinate on that. You're just going to list the y value at the max. So this answer is going to be 3. So notice both of those are referring to the same exact point on the graph itself. But the way the phrasing is on this, if you see the phrase list the number at which or list the number, that is referring to specifically an x value. So whenever you see that on there, that means X value only, we're listing the 0. If it says what is the relative max, that's the Y value only, and that's going to be a 3. Okay, so we have that here. We're going to do what is the relative min. So it says relative min. This again is referring to the Y value. It's not X value because I don't see the phrasing list the number. Okay, so if you don't see the phrase list the number, that means that you're looking for a Y value. So it's only if it says list the number is when you're looking for an X value. Otherwise, it's going to be a Y value. So on this number E here, it says what is the relative minimum. This point right here, this 2, 0 I mentioned earlier, that's the place where the relative min occurs because you have decreasing and you have increasing. But this question only wants you to put the Y value. The Y value there is going to be 0. Okay, so that is the relative minimum. That is it's 0 here because you have decreasing and you have increasing. Now let's actually find what these intervals actually are, the intervals for increasing and decreasing. These you have to list, again, in interval notation. You're not using coordinates for this at all. You're using interval notation for that. Increasing means you're looking for the part of the graph that's going uphill as you move from left to right. Now this graph has 2 places where that occurs. You have this section between -3 and 0, and you have this section, the graph's going uphill, between 2 and 4. All right, so when I put this down here, I'm going to put those between -3 and 0, and I also have it goes between 2 and 4. Now what I'm going to put around here is I'm putting parentheses, and I'm going to always use parentheses on this particular problem. The reason why I'm always using parentheses on increasing, decreasing, well, actually, on this is because usually in the homework, it'll actually say find the open interval at which it's increasing or decreasing. Typically, you'll see that phrasing in there. You'll also see that phrasing on the exam. You'll say list the open interval or write the open interval at which it's increasing. So if it says open interval, that's why you want to include parentheses on this. Now, if it didn't say open interval specifically, then you could actually put it is okay to have a bracket on -3 because that point is actually included. So I'm going to put an or, okay? And if you happen to write this on a test and you didn't make an open interval and it marks you wrong, I'll go ahead and you can go ahead and let me know, and I'll go ahead and I'll fix that. I always actually, by the way, after you take your exams, I always go back and I check your work. And so if it marked you wrong on that, but you had a bracket, this is technically correct, so I would give you full credit on that one. That's why I always go back and double check. So this is actually correct as well, because we have brackets on -3 and 4 because these are closed circles. Now, what you might be asking yourself is, well, why doesn't 0 and 2 have brackets on it? Because those are also closed circles as well. Well, the reason why is because the point at 0, 3, it's actually not considered to be increasing or decreasing. It's actually where the graph is not increasing or decreasing because it stops. And also, you can't have one point that's both increasing and decreasing at the same time. So that's the reason why we're not including the 0 and the 2 here in this case, because that's the one that separates increasing and decreasing. But it is correct to put a bracket at -3 and a bracket at 4. But the instructions specifically to say write the open interval at which is why you can just go ahead and write it like this first one. Excuse me, if it says open interval specifically, then open interval just means that you have all parentheses that are on it. So I want to talk about the discrepancy with that. Now this here decreasing, it goes this section where the graph moves goes from left to right. Now notice that all these values that I had for increasing and what I'm also going to put for decreasing, they're X values only. So when you write the interval notation here, you're writing the X values for which you see the graph going uphill. And for this one with decreasing, you're writing the X values from which the graph is decreasing. The graph is decreasing between the X values of 0 and 2. Now 0 and 2 for sure that you want to definitely have a parentheses on that one, because again, 0 and 2 is where the increasing, decreasing kind of gets split there. And so you can't have a 1 point that's increasing and decreasing at the same time. That's why we're using specifically parentheses from 0 to 2. Okay, so it's only decreasing in this little section right here where the graph is falling as you go from left to right. All right, so let's do another one of these. Okay, so this one here, this one has a couple things from domain and range. It does ask you from the previous section, but we're going to take a look at this as far as increasing, decreasing, and relative max and relative min. All right, so this right here says use the graph to answer the following questions. Indicate the interval or intervals at which f is increasing. Now this time we don't have points labeled for us, so we have to read these off of the graph itself. Now the increasing part, I'm looking for the part of the graph that's going uphill as we move from left to right. Here's one section that's going uphill, and here's another section that's going uphill. The first section here, the graph is going uphill between the x value, because remember, the intervals for increasing, decreasing are only talking about x values. So I know that between -2 and 0, -2 and 0, the graph is going uphill. Remember, we're talking about x values only. We're not talking about -2 or -3. X values only. Between this x value and this x value, the graph is increasing. I have a union because I also have a region in between 3 and 5. Between this x value of 3 and this x value of 5. Okay, that would be the answer there for increasing. Decreasing, I have this section that's going downhill as I go from left to right, and I have this section that's going downhill from left to right. Okay, now the -3, if the questions on the assessment, if it says specifically to use open intervals, then everything's all going to have parentheses, but just know you could put a bracket on -3, and that would be still considered correct. So let's go ahead and I'm just going to use parentheses though for this. So between -3 and -2, the graph is going downhill as I move from left to right. And I also have this section right here. It's going downhill between the x value of 0 and the x value of 3. So from 0 to 3. Again, these are not coordinates here. These are intervals. These are all x values that for each of these. List the number. Okay, so that, again, this list the number phrase means that they want an x value. This wants the x value where there is a local min, where you're going down and you're going up. It just so happens that this graph has 2 places. So this has 2 local minimums. There's one here at -2. There's another one at 3. So what you would put here is -2, 3 is what you would type in for your answer there. It says list the number at which or list the number where. List the number phrase means specifically they just want x values where there's a min. That's going to be at the x value of -2 and the x value of 3. What is the local max? Okay, now, because it doesn't have list the number here, that means specifically it's asking for a y value of the local max. That max is right here. The max occurs at -2, 0. It's not at -3 and 5. Okay, -3 and 5 would be considered absolute max because that's the highest that you see in the entire graph. But that's not asking you for that. It's asking for the word local, which is the same as relative. Okay, so local means just in this area, it goes up and it goes down. Okay, so you want the y value there at that point, and this is going to be at -2. Okay, so the point we're looking at is this one right here. But because of the phrasing, it just says what is, it doesn't say list a number. So because it doesn't say list a number, you're just talking about the y value. So that's going to be at -2. Okay. Next it says, what is the local min? You might be thinking, well, isn't that the same thing that they just asked in part C? Well, it's the same points as part C, but because it doesn't have list a number, it just says what is the local minimums. You want to indicate the y values at the local mins. The y values of each of these will be -3 and -5. Okay, so we have two values for that one, -3, -3, and -5. Okay. I'm sorry, -2. What am I saying? -2 and -5. Sorry about that. -2 and yeah, I should have right the first time. -3. Sorry about that. -3, -5. Yep. So the y value here is -3, and the y value there is -5. It's just the y values here. So again, these here talk about y values. But then this, if you see the phrase list the number, that specific phrase means x value. Now, the last thing we have on here is domain and range. Now let's just go ahead and answer those over here instead. Okay, so I'm going to do F is domain. I'm going to do it here because it's easier to see because we've got the graph shown for us already. So I'll just do them up here. Okay, so domain is talking about the x values that the graph uses. So the smallest x value is -3, and the highest x value is 5. There's a closed circle at -3, but there's an open circle at 5. So I'm going to put a bracket on -3, but I want to put a parenthesis on the 5 because there's an open circle there at the 5. So between -3 and 5, -3 has a bracket and 5 has a parenthesis there. The range is talking about the smallest y value to the highest y value. Now the smallest y value is -5, and then that goes all the way up to the y value of 0. Now the question is whether we have brackets or parentheses on this. At -5, there is no open circle that we see anywhere on here. It's a solid line. So because it is a solid line, that means I have to put a bracket on that one. Now there is an open circle here at 5, but the closed circle always takes precedence over the open circle. Because I have a closed circle here, that means that this point right here is -3, 0. That's an actual point that's on the line itself. So that means that because that point actually is closed circle, that means that the y value of 0 should be included, which means I do need to put a bracket on that one for this. Okay. Again, that's because it is a closed circle, it is actually using that particular y value. So that would be your domain and the range for that one. That was the last one that we had. So I'm actually going to go ahead and stop the lesson here at this point. So we'll pick it up and continue with 2.3 for next time. So now I'll go ahead and I'll just leave it open for if anybody has any questions, we'll answer some questions now. All right, well, I don't see anybody that has any questions at this point, so I will go ahead and I'll end this meeting. Enjoy the rest of your day. I'll see all you guys tomorrow.